Yeah, yeah. A lot of people like they build with it. Or,
Alright, I gotta try that one.
I had to like look right for my own. It's kind of interesting.
I gotta do that next device.
Yeah,
It drives all the way up the market structure, and it takes forever because like you have to like invert them like.
All right, it is 10:30. I'm going to get started. So what we'll do today is I will first go over the homework assignment for set theory. Because it's already done. If you check Moodle right now, I think it will give you the correct answer and the right score already. But I'll just go ahead and go through those questions, okay? And if you guys have any questions, just go ahead and let me know. Let me see. I just need to do a preview. There we go. All right. So there are a few questions, and so this is the questions that you get. The ordering may not be the same because I think I randomized the questions too. So this is the first one that we're dealing with. So if A intersects B, the intersection has the same number of elements as one of the set, which is A in this case. What can we conclude for sure?
B is empty set.
Okay, so let's take a look at each one of the options and find out, which one makes more sense. Okay, the first one is A is a subset of B, not necessarily a proper subset, but it is just a subset. So that's possible, right? Because if A is a subset of B, the intersection would just be A. Is that making any sense? Because one is containing the other one, and A in this case is the quote-unquote smaller set. So the intersection would just be the smaller set. So I have a strong suspicion that A is the correct answer. Now let's take a look at B. B is a subset of A. That doesn't make sense because if B is a subset of A, then the intersection would have fewer elements than the number of elements in A, or potential. And not equal to. C, A is a proper subset of B. So in this case, A is a proper subset, which means there has to be at least some differences between the two sets. But they can be the same. Okay, see the difference between option A and option C is with option A, we are basically saying A is a subset of B, but it can be the same thing as B. With option C, we are saying A has to be a proper subset of B, which means there has to be at least one element that is found in B that is not found in A. So that means, okay, out of A and C, which one makes more sense? A. A makes more sense because it's not guaranteed that A has to be a proper subset of B when the intersection has the same elements as A itself.
Let's say which one can you conclude for sure. You can't really conclude A.
Okay, let me prove you wrong by contradiction, proof by counterexample. Okay, so proof by counterexample is like this. I'm gonna use the little mouse pad here for that purpose. Okay. All right.
You're recording, right?
I believe so. Yep, it is recording. Yep, you just have to make sure I upload it too. As we talked about a little bit earlier. All right, so the question is, if A intersects B, the intersection has the same number of elements as A, what can we conclude for sure? Okay, that's the question. If the answer is, okay, let's say the answer is A is a proper subset of B. Okay, so let's pick option C as the answer. Then I can say, okay, but what about this specific case? What about A being 1, 2, and B being 1, 2? Okay, so if you look at the definition of set A and the definition of set B, it certainly meets the requirement. It meets the premise, right? Because in this case, what is the intersection of set A and set B? Will be, it will have the elements 1 and 2, right? So the intersection would have the same number of elements as set A in this case. So if you pick, number of C as an option, as the correct as the answer, then it's not, it's not guaranteed. Yep.
But isn't A just a subset of B from that?
In this case, A is a subset of B, but it's not a proper subset of B.
Is that what you're proving?
I'm proving that C is not the right answer. Yep.
Just with the wording though, it made it seem like if A and B were not equal, then C would be true and A would not be true. But so I'm just assuming like for sure. So like let's say B and A were not the same set, then A would not be true, right?
This question is asking, if I tell you ahead of time that the intersection of set A and set B has exactly the same elements as set A, what can you conclude? You cannot conclude that A is a proper subset of B because this is a counterexample of B cannot be a proper subset. We know it has to be a subset, but it can be the case that it's not a proper subset. Is that okay?
But that's only one instance. It's not every time. I just thought like just the wording.
Then it's not for sure.
Yeah.
If I can find one case where the claim is not true, then you cannot say it is for sure if it is not always true.
I mistook that the other way around. Just the
Okay.
wording.
All right. So the answer is actually A in this case and not C. But it is important to understand why it is A and not C. Okay. This one does not work either. B is an empty set. Okay, let's think about that. Okay, what happens when E, in case E or choice E, what happens when E is an empty set?
The resolution is the empty set.
Yep, exactly. Well, it is possible because if A is an empty set, B is an empty set, the intersection is going to be an empty set. So it will still meet this requirement. But just knowing that the number of elements of A intersect B is the same as the number of elements in A does not guarantee that E has to be true. It can be true, but it may not be true as well. Okay? So let's take a look at the next one. Okay, this is the next one. Which of the following is true about the empty set? Select one. The empty set is not a set. Well, that one is kind of like a I have to come up with enough wrong answers just to make it interesting, and some of these are completely bogus. Well, if it is not a set, people would not have called that an empty set, right? Okay, so we know it's not A. An empty set is not a subset of itself. It is a subset of itself, okay? Because it's a subset of every set. C, the intersection of any set A and the empty set is A. No, that's not right. Okay, the union is true, but not the intersection. D, the number of elements of an empty set is greater than 0. Well, an empty set by definition has no elements, right? So the number of elements in an empty set has to be 0, cannot be more than 0. And the E is an empty set is not a proper subset itself. I think of itself, it's grammatically incorrect. But E is the answer. An empty set is not a proper subset of itself. I apologize for missing that word, the proposition. Did you guys get thrown off by the of?
Yeah,
No.
I did, but then I decided to choose it.
Because the other ones are way off, right?
Yeah, they are way off.
Yep.
So I was like, this one's
Okay.
I didn't even notice. It's like just said that.
Had enough classes.
Yep, exactly. It's getting worse. You're learning my English. Okay, question number 3 is, let set A be 13954, okay, and B is 14 as a set. Which of the following choices are true? So in this case, it'll select one or more, okay, which means at least one, but possibly more than one. So the first one is A minus B is an empty set. That's not right. Okay, I can definitely find elements that are in A but not in B. B is an element of A. No, it is not true. A set cannot be, well, okay, I shouldn't say that. In order for B to be an element of A, the entire set B has to be an element of A, which is not the case here. Okay, so B is an element of A is not true. Okay, C is B is an element of the power set of A. That is true. All right. B minus A is an empty set. There are no elements in B that I cannot find in A. That is true. A is a proper subset of B. That is not true. So in this case, C and D are the correct answers. Are there any questions about this one? Yep.
Choice B.
Choice B.
What all of A have to have for B?
A will have to have the entire set 1, 4 as an element. As an element, right? In other words, if we kind of talked about this last time when we talked about the power set. So in this particular question, if I changed it so that A is 1, 3, 9, 5, 4, and a set of 1, 4, like that. In this case, then what is the number of the option? So in this case, B would have been true. But because the set of 1, 4 as an entire set is not an element of A, and so we cannot claim that B is an element of A.
What if B consisted of only just 1? Instead of 1, 4, or just 1, would it be?
It depends on whether it is still enclosed by curly braces. If it is like this, it's not an element because you need both 1 and 4 in a set, and that set being an element of A in order for B to be an element of A. Okay. Good question. Okay, it's much better to have this all cleared up in a homework assignment than in the test, because in the test it would have more weight and it's going to do more damage. But in a homework assignment, it's not going to be as bad. All right. Any other questions related to this one? Yep.
Is there any kind of formal definition for what you mean by an element?
An element is just one thing within the curly braces. That's kind of the syntactic definition of an element of. Any other questions? There's no question of why I specifically picked 1, 3, 9, 5, 4. No. Nobody wants to know. Okay.
What is it?
What is it? It's the license plate number of Takumi's 86 in initial D.
You've been watching too much anime, I guess.
Yeah, I think so. Okay, number 4. Given that the number of elements of A, which is a set, is 5, what is the number of elements of the power set of A?
2 to the power.
2 to the power of 5, which is
32.
32. Yep, that's right.
Those are the magic numbers.
And here we have question number 5. Let A be a set, but it is not just a regular set, it is a cross product, it's a Cartesian product of 1, 3 as a set and 1, 3, 7 as another set. Do you guys have a question back there? No? Okay. If you have a question related to the class stuff, let me know. And we'll let T, using lowercase for a particular reason, to be a tuple of 1, 3. Okay, it's a 2 tuple of 1, 3. Which of the following is true? Now, when we have parentheses, it means it is no longer considered a set. Okay, it is called a tuple, an ordered list. Since it's not a set, can it be a subset of something else? No, cannot be, right? So A cannot be true. Okay, let's take a look at B. Is T an element of A? Yes. Yep, it is. But just to be sure that I'm not missing anything, we'll consider all of the other options. C cannot be true for the same reason that A cannot be true, because lowercase t is not a set. Because it is not a set, it cannot be a subset or a proper subset of another set. So C cannot be true. D, since T is not a set, we cannot even talk about the intersection of T with a set because it is not a set. And E cannot be true either because since it is not a set, the subtraction or the difference operator cannot work on it. So the only thing that can work in this case is B. Are there any questions about this question? No questions? Right. Moving on to the last question. There are only 6 of them. You are given 2 sets, A and B. You are also given that A intersect B as a set has only 1 element. And you also know that A union B has 9 elements. From this, what can you deduce to be the minimum number of elements in A alone? Yep, that's all you can conclude. It's just 1. Okay. Because in this picture, if you want to draw a Venn diagram, it's really helpful. Because if you consider the red portion as A, and you consider the blue portion as B, we are basically saying, if you look at the entire union, it has 9 elements. But when you look at the intersection, which is this part here, it has 1 single element. Well, if the intersection has 1 element, that means A must have at least 1 element. Now, whether A is really a proper subset of B, we don't know. Because it is possible in this case that A is just a subset of B and it has 1 single element. But it is at least 1 element. Is that making any sense? Okay. So we don't know how those 9 elements are distributed between A and B. We just know the intersection has exactly 1, and that's why the number of elements of A has to be at least 1. That's it, I think. Let's see how I score here. Submit on the finish, double confirm, and does it give me a score?
No, that's what I was telling you about the other day. It doesn't do that once you submit it. You have to grade it.
No, I don't have to grade it. It's because it's before the due date. So before the due date, it won't show you the actual grade. If you check now, I think it will give you the grade.
Yeah.
But I think those are the correct answers. All right.
This is out of 10 points.
This is out of 10 points. 6 questions out of 10 points. I know it's going to be a fractional thing for some people. I just checked this morning, and quite a few people, if I look at the histogram of the scores of this test, the majority are scoring 10 out of 10. So it's not too bad. Any other questions about this particular homework assignment? Did you guys spend a lot of time on it? A little bit of time? Or you just go like, click, 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 I'm done?
10 minutes.
10 minutes? Okay. Maybe 10 minutes to about 30 minutes or so. Once you understand the material, it wouldn't take that long. It might take you more time just by having to go through the symbols to understand what each symbol actually means. That will take you more time. Okay. All right, so with this out of the way, we're going to go continue to talk about functions. And the homework assignment, the quiz corresponding to function, is postponed by 2 days, so it's next Thursday is the due date. I could see this morning that 3 people have started on it already, which is a good idea. Okay, always start early, so you know the questions. So when I talk about the concepts, you can say, "Oh, hold on a second here. I need to know more about this one." All right. Last time we were talking about a little bit of first-order logic, or also known as predicate logic. We will focus on predicate logic at some point because it's really important. It's very, very important when it comes to a program validation. In other words, has anyone heard of a programming language called Prolog? Okay, and Prolog is all about first-order logic. Okay. It's an engine that can automatically prove theorems when you give it, all the predicates. All right. You guys okay? Any questions from you guys? No? Okay. So last time we talked about the symbols. I fixed my notes too. I use a subset of instead of proper subset of when that is actually the proper one to use. We talked about a good portion of this already. Did we finish this last time? I think we did. I think we finished this, completely. Then we ran out of time, and that's why, I had to postpone the due date of the homework assignment because we couldn't really quite get into injective and surjective functions. That's what we're going to do today. All right, so this is about what is an injective function. Okay, so when we look at this, we look at you can look at the English description first. An injective function maps elements of the domain to unique elements in the codomain. Okay, so that's the only requirement in order for a function to be called injective. So basically, if you have two different elements from the domain, what they map to in the codomain must be unique, must be different. That's the only requirement. So we can also express what I just said in English using first order logic. So using first order logic, this is just a step in between. Is we will consider one element x1 in the domain. We'll consider another element x2 in the domain. Okay, so now at this point, just with the highlighted portion of this statement, we would have what we call bound two particular variables. The first one is x1. It has to be an element of x as a domain. The other one is x2, which is also an element of the domain x. Okay, but we don't know anything. We have not stated anything about x1 or x2 at this point. We're just saying, okay, randomly pick x1 and randomly pick x2, and then we'll go ahead and look at the rest of it. So what we want to do is to say x1 equals to x2, so they're exactly the same element. Then it's true already. We don't have to look at the right-hand side of the disjunction. In other words, if I pick randomly, but I just end up picking up the same element, there's nothing I need to say. Okay, because being injective doesn't apply to when you only have one element to consider. So that means the other part of the disjunction is only something that I need to specify when x1 and x2 are different. Then I really have something to say about it. So that's kind of how this is set up. And when you think about what we actually have to say about x1 and x2 when they are different, it will be this part here. Okay, so let's take a look at just that part. And I can zoom in even more. And this is the nice part of using, well, maybe not that much.
There you go.
We're still missing some close parentheses, but I can scroll like that. There we go. So if we just take a look at the highlighted portion of this statement, let's see what it's saying. The first part is saying x1, y1 as a two-tuple is an element of F. All that is really saying is x1 maps to y1. Is that okay? In other words, it's really saying f of x1 is y1. That's another way to say the same thing. The second portion, which is here, is doing this about the same thing to x2. It's basically saying f of x2 is y2. Well, that part is nothing surprising to us because f is a function after all. It has to map everything from the domain to something in the codomain. So what I really need to say is how y1 and y2 should relate. And in this case, I have to make sure that y1 does not equal to y2, which means x1 and x2 as different elements from the domain, they have to map to different elements in the codomain. They cannot be the same. Do we have any questions about how I express injective functions? Yep.
Can you do an example on the board?
Absolutely. Yep.
Basically mean the function's one-to-one.
Almost, okay. One-to-one may imply it is also surjective. So we'll take a look at surjective too. One-on-one, can be a part. This, to some people, this can be one-on-one, but you have to be careful because some people also imply surjective when they say it's a one-on-one function. But We'll talk about surjective, right after this. Okay. So the simplest example I can give you as a function that will do this is, I'll use my mouse pad instead. My mouse pad, I'll give you an example. So we'll take a look at this function f, and we'll say function f is going to map this particular set from, okay, this is good. Okay, Tack and George. And we'll use a Cartesian product to a set of cars, right? So we'll just reuse the example from last time. So we'll cross it to Miata, 745, and we'll pick a car that neither of us like, Skylarks. Many of you do not know what a Skylark is because Buick has discontinued the Skylark model a long time ago. Well, by your standard, a long time ago.
Was it 15 years?
No, not quite. All right, so f is going to be a function that maps the two names, me and George, to another set which consists of 3 different types of cars. But that really doesn't tell you how everything is mapped. So I will give you the exact mapping here. So in this case, I'll tell you exactly what f is. F is a set. Every function is a set of tuples. In fact, it is a set of 2 tuples where the first one has to come from the domain and the second one has to come from the range or the codomain. So in this case, it will map me to Miata because I like Miata, and it will map George to 745 because he likes 745. And that will make a injective function because it meets all the requirements that we were talking about. Is that okay? What about Skylark? It is okay to have stuff in your codomain that is not mapped. Okay? It doesn't make f a non-function. It simply means there are certain elements in the codomain that is not mapped, and that's perfectly okay. Any other questions? Yep.
Yeah, so what's the x1 and x2
In this example, well, x1 and x2 are variables. Let me go back to the notes and explain that part. Okay. So x1 and x2 are basically variables. If you just kind of look at this part here, okay, so without any specific information about an injective function, what this means is for all x1 in x, okay, in the set x, and for all x2 in x. So that is when x1 is bound to one particular element of the domain, you have to consider everything in x as well as x2. It's kind of like a for loop inside a for loop. If you want to look at this as kind of more programmatically, it means this one here. Okay, let me go back to my mouse pad. So I think doing this may be a little bit dangerous because some people may misunderstand this being a programming concept, but you can kind of think of it like this. You can say for each x1 in x as a loop, and then inside this loop you have another loop that says for each x2 in x, and inside here is something that has to be true, considering x1 and x2. So in this particular case, I'm going to say x1 equals to x2, or the other part. So this statement that I'm typing right now has to hold true for all possible pairs of x1 and x2. So from the programmatic perspective, this is kind of what it's saying. I'm using pseudo syntax here because Perl has a for each, but it doesn't say the word in is a for each. It just says x2 and then in parentheses you specify the list. But I'm hoping most of you understand the context of what I'm doing here.
Isn't there more to the Cartesian product though, besides those two?
Sorry?
Isn't there more to the Cartesian product? So it would be like tax Miata, tax 745, tax Carlark, George Miata, George 745,
So, okay, I think I kind of shortcutted it a little bit. Okay, first of all, I have to indicate this is a map from here to there. And then the other part is to say that this is a proper subset of the two crossing, the Cartesian product of these two. Okay, is that what you're talking about?
Yeah.
Yeah. So I shortcutted a little bit. So the first part basically is, indicates what is the range, what is the domain and what is the codomain. The second part, which is this part here, is the actual definition of the function, which has to be a subset of the Cartesian product of the domain and the codomain. All right. Any other questions? Yeah.
Can Tack and George map to Miata?
As a function, yes, but not as an injective function. Because the property of an injective function, what makes a function injective is if you pick two different elements from the domain, they have to map to different elements in the codomain. Or the other way to say that is no two elements of the domain can map to the same element in the codomain. That's the other way to say that. So if you have a domain of only one element, that has to be, by definition, injective, because you don't have a second element to consider. Are there any other questions about all this stuff? No questions? Okay. So the next one is surjective. Okay, so this is surjective. A surjective function, so I start with an English description first, and then I'll use the kind of more mathematical description. A surjective function has each element of the codomain corresponding to an element of the domain. In other words, you have to use up everything in the codomain. You cannot leave some elements in the codomain unused. That's the meaning of being surjective. Okay? Being surjective does not imply injective. Okay, so you can have functions that are surjective but not injective. This means that a function like the following is surjective, but it is not injective. Let's take a look here. So we have a function here, f. The domain is 1, 2, 3, 4, 4 numbers. The codomain is x, y, z. And the function is defined as such. Okay. So I map 1 to x, I map 2 to x, I map 3 to y, I map 4 to z. It is a function because I use up everything in the domain. It is not injective because I map both 1 and 2 from the domain to the same element x in the codomain. But it is surjective because if you look at the second item of the tuples, x, y, and z, they're all used up. So every single element in the codomain is mapped to. And that makes it surjective. But this is injective. This is not injective, but surjective.
Could you have both? Like, could some function be subjective and injective?
Absolutely. You can have both, or you can have none. You can have a function that is neither injective nor surjective. So the 4 combinations, you can have examples of each in the 4 examples. And I think in your test, in your homework assignment, you have to give me examples like that. I should have said in the questions, and it is kind of implicit that you cannot use my examples in class. Right? I mean, that kind of makes sense. Are there any questions about surjection or surjective functions? Yep, go ahead.
Does everything in the domain have to be mapped?
Yes.
As well?
That's the whole point. Is everything, every single. Okay. In order for f to be a function, everything in the domain has to map to something. So without that, f is not even considered a function. So what makes it a surjective function is everything in the codomain also needs to be mapped. Well, that means if your codomain has more elements than your domain, it automatically makes the function what can we say about a function where the domain has more elements than the codomain? It's one thing that you can automatically conclude.
The domain has more than the codomain?
Yes, yes. So I'll give you an example.
It has to be a surjective function.
You're on the right track. You're on the right track. So I'm going to give you an example here. So f is a function. The domain is 1, 2, 3, and the codomain is 1, 2, 3, 4.
Oh, you said it the other way.
Right.
You said it
Did
the
I?
other way in your example.
Did I?
Yeah.
Okay.
So that's it.
Sorry about that.
Function.
Okay, so the number of elements in the domain is less than the number of elements in the codomain. Correct myself, but this is what I meant. So with this setup, without even knowing how elements are actually mapped, what can you conclude, like right away?
Not surjective.
Sorry?
It cannot surjective.
It cannot be surjective, exactly, because you have more elements in the domain. In order for a function to be surjective, everything in the codomain need to be mapped. But since you only have 3 things to map to 4 things, something has to be unmapped in the codomain. So that's why this is automatically a non-surjective function. Cannot be surjective.
There's no way to have anything in the domain mapped to 2 different things?
It cannot, because that's a part of the requirement of being a function is you can only map something from the domain to only one thing in the codomain.
For functions in general, like all functions?
It applies to all functions. Yep, it applies to all functions as far as math is concerned, but it also makes sense for subroutines. Okay, when you look at the function as a subroutine, if your subroutine, because every time you run a subroutine, it only returns a value. Yep.
So you say here that this is not surjective because you have more in codomain than stuff that you have in domain?
It cannot be surjective because we have more elements in the codomain. So no matter how you map elements in the domain to the codomain, at least one element in the codomain will remain unmapped.
Well, you used one in your previous example. You had 1x, 1x, 1y.
No, it cannot be 1x and 1y because if one maps to both x and y, then it's not even a function.
Can you just go back to your previous example? Can you go to your previous example?
The previous example, like up here
In your notes.
in my notes, this one?
Yeah, so. Oh, okay. You have it too.
Yep.
Okay.
Yep. Are there any other questions about in what is required for a function to be surjective? No questions? All right. Next, let me just kind of scroll down to make sure that I don't miss anything important. Okay, so mathematically speaking, how do you know a function is surjective? So in order to say that it is surjective, you can kind of say it this way. You can say for all y which are elements of the codomain, okay, so in this case y is a codomain, you have to show that the set of elements from F where something is mapped to y has to be greater than or equal to 1. Now it doesn't have to be 1. It only has to be greater than or equal to 1. Because in this case, once I lock down what y is, so for all quantifier, it's going to lock down y. Okay, so by the time you evaluate whatever is in the parentheses, we know, okay, we're considering this thing as y. So it doesn't matter which y you pick from the codomain. If you consider a set that is consisting of elements from the function itself, but since we have locked down y already, the only thing we can change will be x, right? So if you consider everything that can map to y and turn those into elements of this set that has no particular name, the cardinality or number of elements in this particular set has to be greater than or equal to 1. Doesn't have to be 1. Okay? It only has to be greater than or equal to 1. Is that okay? Any questions about this statement? fact, the example that I gave you, if you consider, let's see, if you pick x here and you put that into this particular variable y, then we have a cardinality of 2, because 1x is one element in this set, and then 2x is another element of the same set. So we have two things that can map to element x in that case. Any questions? Yep.
It's not relevant to this point, but the thing is, like, your definition of function is there's whatever you have in the domain can just point to one thing, code domain, right?
Correct.
So
One
for
and
example,
only one.
okay, so for example, if your function is your root of integers, it can point to two things at the same time.
That would make it a non-function. It is not a function.
So when you're taking a root of 4 and it points to 2 and -2, is that a function?
It is not a function. By this definition, it is not a function.
Okay, like
Now squaring is a function. Okay, that's a good way to put it. I'm not sure. I'm not going to give away the answer of one of the questions. I vaguely remember there's a question like this. Okay, so let's not use squaring. There are other functions of the same nature. Okay, so let's take a look at sine. Okay, sine of theta as a function. Okay. So if you look at sine as a function, what does it map to? Map from, and what does it map to? So sine as a function is going to map. What is the domain of sine? All real numbers, right? Okay. So all real numbers typically will be written like this. It's kind of like a funny looking R, with two bars and stuff like that. And what does it map to? Not all real numbers, right?
-1.
It maps to
1 to -1.
1 to -1.
-1 to 1, pick your pick, right? So I'm just going to use this notation to say, -1 to 1 inclusively, because it can be -1, it can be 1, and everything in between. Is that okay? Well, it is a function, because every single real number, you can apply the sine function to it and get to one of these values. Is it surjective? In other words, are all possible numbers in the codomain correspond to at least one number as theta?
Yes.
Yeah. Okay. So that makes sine a function for one thing, because everything that you can pick up as a theta only has one and only one value to map to. But it is also a surjective function, because every single number that I use in this range here, they are all mapped to. Well, let's go back to injection. Is it injective? It is not injective because
Multiple values of x correspond.
Yep, because theta plus 2 pi, theta plus 4 pi, they all map to the same thing. All right. So that's good.
I have a question.
Yep.
It's like the function over there is not one-to-one function, right? The 1, 2, 3, 4, the 1x to x.
It is. Well, it's not one-to-one.
It's not one-to-one.
Well, okay. When we say one-to-one, it's not in the terms that we have talked about, but it's not injective, because in that case, both 1 and 2 from the domain, they both map to the same element x in the codomain. But it is surjective because everything in the codomain is used up. All right. So let's move on to the next one. Bijective function, which is really kind of boring, because bijective simply means it is both injective and surjective. That's all. So I'll give you another example, okay? And you tell me whether it is surjective or not. I mean, bijective. Let's look at f of x being x plus 1. Is it injective? Yes. It is injective because for every possible value of x, it will map to a different x plus 1. If x and y are different, f of x and f of y must be different. Is that making any sense? Yeah. Okay. Is it surjective? Okay. Now, when we talk about surjective, you have to be careful about the range and the domain, or the codomain and the domain. So if we just look at f as a function that will map from all possible integers to all possible integers. So under this constraint, is f surjective?
Yes.
Yep, it is surjective. Since it is both injective and surjective, it is also called bijective in this case. That's it. Bijection is just combining the two, injection and surjection. Are there any questions about the verbal definition of what is being bijective? It's really just a combination of the two concepts that we have talked about earlier. Now, why do we want to call it a special name if it is really just a combination of being injective and surjective? Well, the reason is because if it is both injective and surjective, there are fun things we can do with it. Okay? And the fun thing that we can do with it, a bijective function is also known as one-to-one. So that's the qualification of one-to-one. It is not just being injective, because you also need the surjective part so that the reverse would also work. If it's only injective, the reverse is not going to work. You cannot just pick something in the codomain and say, I want to see who mapped to me, because something in the codomain may not be mapped at all. So is that kind of answering your question earlier? So if I give you a bijective function that is a function that is known to be bijective, and it maps from domain X to codomain Y, and by the very nature this is bijective, we already know there's an inverse function. It has to exist that will map from Y back to X. And this would not be possible if we are missing one of the two. Okay, this would not be possible if we're missing injective or surjective. It has to be both injective and surjective in order for the inverse function to exist. Are we doing okay so far with this? Because if it is not surjective, then something in Y does not map to something in X. So that makes the inverse function not even a function. If it is not injective, that means multiple. Let's see. If it's not injective, that means the same thing in Y, the same element in Y can map to two things in X. That also makes it a non-function. So that's why both injective and surjective are necessary to make the existence of an inverse function possible. And to express the inverse function, all you have to do is to say, for all possible X and Y that are in F as a set, Yx as a two-tuple has to be an element in the inverse function, because it's just reverse mapping it. Is that okay? Any questions about bijective? Because it's kind of like a special case, but it's also very useful. Bijective functions are far more useful in many cases than functions that are just surjective or just injective. Yep.
So an inverse function would just look like each ordered pair is just reversed?
Yes. Yeah, because that's its function. Because it's basically saying for everything on one side, there's exactly one and only one unique thing on the other side. So that means the direction can go both ways. And that's why we just reverse the direction. Because when you look at a two-tuple, it's really just a map. Okay, it's really just saying, oh, if you have this on one side, it maps to that thing on the other side. Any other questions about bijective? Yep.
So the inverse function is also a bijective function.
Again?
The inverse function is also a bijective function.
Yes. Yep. Very good. So I'm just going to repeat that so that the recorder will record it. So if f itself is bijective, then an inverse function has to exist, but the inverse function itself also has to be bijective. Because a function is its own, okay, I take it back. Because a function's inverse, okay, no. A function is the inverse of its own inverse function. Is that making any sense?
Yeah.
Yes.
So if you express it mathematically, so a function's inverse function, if you take the inverse of this one, it is just the original function. So that this fact makes what you state has to be true. All right. So we are coming along pretty good. Composition of functions. A composition of function is one that can be broken up into two functions or more, applied in a quote-unquote stack manner. So we'll go ahead and take a look at this particular example. F of x is 3x plus 5. It can be considered as a compound function and a non-trivial compound function, because we can always make trivial compound functions, and we can do it all day long, and it'll be super boring. The reason why I said that is because we can define function f to be just that. Is that a function? Well, let's take a look at this function here, because it also has some interesting properties. Is this function injective? Yes, it is injective. Okay, so if I give it two different numbers, then the end result will be different. Okay. Is this function surjective? Assuming the range and the domain and the codomain are the same. It is also surjective. Okay, it's injective and it's also surjective, which also means the inverse function has to exist, right? But the inverse function is really just itself. It is its own inverse function. So if I define g of x to also be x and h of x to be x, I can do this all day long. So anything can be expressed as a compound function, right? Because now I can say f of g of h of x is just x, and I can do this all day long, and this is no fun at all. Okay, but when we look at the highlighted function on the projector, which is f of x is 3x plus 5, it can be broken up into two non-trivial functions, which means they're not identity functions. They're not like these ones. Okay? The way we can break it down is we can break it down into the first function, which is just multiplying by 3. So in this case, I break it up into g of x, which is only responsible for multiplying x by 3. And then a second function, which is h of x, which is just adding 5 to whatever you give it. So in this case, f of x can now be expressed as the compound, as the combination or the composition of h and g. You have to apply g first, because the 3x or the 3 times multiplied by 3 has to occur first, and then you apply h, which is going to do the plus 5. So do we have any questions about this portion here? And let me just highlight the portion that I'm talking about. This part here.
So whenever you're doing the composition, you follow order of operations.
Correct. Because otherwise, if the order is incorrect, then you end up with a wrong result. Because if you apply h first and then g on the outside, then you end up with x plus 5 in parentheses and then have the 3 times on the outside, which is not the same thing. Mathematically, yep, go ahead.
Are you using composite and compound function synonymously?
I should have used composite all along. Yep. So this is a composite, so we can say that f is a composite of g and h. But in this case, the ordering is important, because this implies that g has to be applied first, and then we apply h. Okay. Are there any questions about just the notation, and also how we can take one example like this and break it down into its component functions? No questions? Okay. All right. So for this particular composite function, okay, let's take a look at the individual component. Let's take a look at this one here. And we'll go ahead and consider real numbers as both the domain and the codomain. Okay. If we consider real numbers as the domain and also the codomain, is that function injective? If x and y are different, would g of x and g of y also be different? Yeah. So it is injective. What about surjection? And considering the real numbers, all real numbers as the domain and also the codomain, it is also surjective. So that means it is bijective because it is both injective and surjective. So it is bijective, which means it has an inverse function. Okay. What about h? If I look at h and we use all real numbers as both the domain and the codomain, is it injective?
Yes.
What about surjection? Is it surjective? It is also surjective, which means it is bijective. It has its own inverse. Okay. All right. So if both component functions of a composite have inverse, then the overall composition itself also would have an inverse. In fact, if you can find an inverse for G, you'll put it here. If you can find an inverse for H, you'll put it here. So if you look at the composite of the inverse of H and then the inverse of G, you will actually, that becomes the inverse of F itself. Are we doing okay so far with this? Yep.
What's the symbol between the H and the G again?
Between the H and the G?
Yeah, like the F equals
That little
G
circle
and
thing?
Yeah.
It's a symbol that means composition.
Oh, okay.
So when you have a composite function and these two are the components, it is just a separator, so to speak, of the two, but the order is important. Okay. So we'll use this as an example and say that, okay, but I'm not really sure that that really is true. Okay, can we really get to the inverse function of the composite just by looking at the inverse function of the individual component functions? Yep.
There are two x possibilities that would equal the same codomain, I would think.
Go ahead, give me an example.
A negative number and a positive number could potentially come out to the same answer, correct? Like if you had a very small, I guess I could try and work one out.
Okay, are you talking about G or H or F?
For fx.
For f of x?
Yeah. Does it fit? You're trying to work one out, but 3 times -1.
I'm fairly sure that one is bijective. It has to be injective and surjective. But you can try to work out a counter example. Okay, so we'll go ahead and take a look at the inverse functions. And I can either do it here, which is okay. All right, so g of x is 3x. What is the inverse function of g of x in this case? Okay, so since I cannot use the superscript, -1, I'm going to use a prime instead. Okay, so I'm going to use a prime to mean it is an inverse function. Okay, it's just x divided by 3, right? H of x is x plus 5. So what is the inverse of that? X minus 5, right? So now we want to take a look at what is h prime of g prime of x. Now, how do we get this done? How do we work this out? There are two ways to do it. You can expand g of x first. So g of x is really just x divided, g prime of x is x divided by 3. So we have that. And then you can apply, yep.
I think we have to apply the h prime first because it's the h prime. We have to do opposite when doing inverse.
Let's see. You're right. Okay. You have to apply h prime first. So g is on the outside, g prime is on the outside, h prime is on the inside. That's right. Okay, so we have h prime is expanded to x minus 5. And then we expand g prime, which is the whole thing, x minus 5 divided by 3. So now the question is this really the inverse of what we talked about earlier in class? Remember f of x? F of x is 3x plus 5. So the question is this the inverse of that? How do we check that?
Replace x with the inverse.
We can plug it in, right? We can just plug in what I have already highlighted here into the x of f of x. So let's go ahead and try that. So now we want to say, okay, what is f of x minus 5 divided by 3. Okay, so by definition, it is 3 times that thing plus 5, and that thing is just whatever we have in parentheses. So we just copy and paste it here. But then you can see that we have a 3 times on the outside, we have a divide by 3 in the inside. They cancel out. So now we end up with x minus 5, that's one thing, plus 5. But since we have the associative rule of addition, so now we can regroup the negative 5 or minus 5 and the plus 5. They cancel out each other, and now we have just x left. So in fact, we can come up with the inverse function of a composite function by combining the inverse of the component functions in a reverse way.
That's very dense.
Yep, I cannot say that again. Yep.
So before we said decomposition spells order of operations, but now that's different.
No, it's exactly the opposite. The inverse function, or if f is the composite of g, h, applied in that order, you apply g and then h, the inverse function has to be applying h prime first, or h inverse first, and then you apply g next. Right. So why do we even talk about these things? I mean, they're kind of cool things to know. We can now label, functions of different kinds, but why is it even important? So I'm going to skip binary relations for now and skip all the way to application of functions, just so that I can tell you guys, why functions are important. Do you guys still remember that whole thing about, how can we tell that a sorting algorithm is doing its job? Remember that? Vaguely, maybe? Okay. So we're going to go back to that example. So we have initial values of an array, okay? And this will define the initial state of a sorting algorithm. You are given an array A, which has n elements. And this is the initial state. I'm just using this to express, how things work when you start the algorithm. A bracket I, which is an element of A, which may not be sorted at that point. I'm just saying that k subscript I is the initial value of that particular element in array A. Is that okay? Are there any questions regarding this notation? This gives me the ability to denote the initial values of each element, the initial value of each element of the array, which is k bracket I, or k subscript I. Are we doing okay so far? Because I will need k subscript I later on to make sure that every single value that we start off with is in the final array A. Okay, because that is one requirement of sorting. You cannot just reinitialize the entire array with a different value and call it sorted. So the end result is if the array is actually sorted, that means we can. Oh, this is kind of big. I'm just trying to find out how to look at this one without a whole lot of scrolling. Looks like that's not possible. Let's do it this way. We'll do it step by step, so this way, I can talk about the first part, and then we don't have to deal with it again. Okay. So in order for a sorting algorithm to be doing its job correctly, we'll say that there has to exist a function f in this case. So f is a function, and it maps just integers 0 all the way up to n minus 1, which are the valid indexes for this particular array, to the same set. Is that okay? So we start off with n numbers. They're all valid indexes into array A, and we map all of those indexes to another index. Is that okay? Now, this is really just saying what is the range, what is the domain, and what is the codomain of this function. Then we say f also has to be bijective. In other words, it has to be injective and surjective at the same time. Are we still doing okay so far with this assumption? So there has to be a function f that meets these requirements. It has to map from 0 to n minus 1 to 0 to n minus 1, and it has to be bijective. What else can we say about this function f that has to exist? The rest of this stuff here. Okay, so we'll go ahead and just take a look at this part here. So what this is saying is for all I, and I being from 0 to n minus 2, not n minus 1, because we have to stop one element short in order to compare neighboring elements. So we say that for all I such that it goes from 0 to n minus 2, whatever follows in parentheses has to be true. So I'll go ahead and highlight just the portion that we are now referring to, which is this portion here. All right. What is it saying? Well, let's break this up into its two components. The first component, actually I got this wrong, a little bit wrong, but you guys can probably tell me why it is wrong. Okay, the first part is only saying that a bracket I, after we run the algorithm, element I of array A has to be the same as the initial value of some element in the array when we first start. Does that make sense? No? Okay. Let me say that again. A bracket I is now reflecting the value of elements of a particular element after we run the sorting algorithm. Okay? And this is saying that it has to be the same as the value of one of the elements of A before we run the sorting algorithm. Is that making any sense? Yes or no? Okay, let's take a look at a really concrete example. Okay, I'll just use an array of 3 elements. This is a concrete example. Okay, so a bracket 0 had a value of 3 to begin with. A bracket 1 has a value of 1 to begin with, and then a bracket 2 has a value of 5 to begin with. Okay, that's the initial state of a sorting algorithm. Right? So if the algorithm does its job correctly, then the output, or at the end of the algorithm, a bracket 0 should have a value of what? 1, and then this would be 3, and then the other one would be 5. Is that right? So all I'm doing here is to label this guy to be k subscript 1, this is k subscript 2, this is k subscript 3, so that I have 0, 1, 2. Okay. So I have a way to refer to the initial values of elements in the array. Okay? That's the whole purpose of the case. Okay? K subscript something is really just referring to the initial value of elements in the array. So the requirement is this guy, okay, it needs to have a value that is one of the values from the beginning. That's basically what it's saying. Because if you just want to enforce the second part, let me just highlight the second part, then it's easy. If you really just want this particular requirement and not really care about the first one, the left-hand side of the conjunction, I can just re-initialize the entire array to -1, -1, -1. Then it will meet that requirement. But would I call this a sorting algorithm? Nope. And that's why we need the component on the left-hand side of the conjunction, because each one of these, each one has to correspond to a unique value from the initial state. Is that part okay? It is also important for function f to be bijective, because I don't want to say, oh, we just need to pick something over there from the beginning. Fine. That's sorted. It's not sorted, right? Is that making any sense? Does it make sense that why I need it to be bijective? So I'm hoping this particular concrete example is helping you. Yep, go ahead.
How do you keep the function bijective if you have like elements
that are
non-years have multiplicity of 1? So like if I have 3 elements
a good question. Okay. So let's start with that. Okay, this is the input of the sorting algorithm. They are all the same value. Okay, and obviously the output should be that. Is that okay? But what I'm stating here is I have to find a function f to map k0, k1, k2 to a bracket 0, a bracket 1, and a bracket 2 as the output of the algorithm. It only has to exist, right? So in this case, I have quite a few choices to pick. In fact, I have 6 choices to pick, right? Because I can now map, I can map 0 to 0, 1 to 1, and then 2 to 2. That's one mapping that will work just fine. I can pick 0, 1, 1, 2, and then 2, 0. That will work as well. So I have many choices to pick in this case. But they are all bijective. And the requirement is you only have to say that there exists at least one mapping to make this work. There can be multiple, I don't care. You just need at least one. Okay. But I also said there's a flaw in this particular statement. Where's the flaw of this statement? There's one element that is not really accounted for. So which element is not really accounted for, and it can be something not from the original array?
You didn't specify that, like the next element in the array is going to be larger.
No, I did. That's it. Whatever is highlighted right now is exactly stating that.
Okay. Never mind.
Yeah. So a bracket I has to be less than or equal to a bracket I plus 1, and that's referring to elements of a after the sorting algorithm is done. Okay. But there's one thing that I have missed.
Is it n minus 2?
It has to do with the n minus 2, but what am I missing? If I use this as the qualification of a correct sorting algorithm, the algorithm can do one wacky thing that will break it.
The last element can be the max A.
Exactly. Okay. It doesn't say anything about the last element. It has to be coming from the original array. Because I is only going from 0 to n minus 1. And so this I can only go from 0 to n minus 1, which means the enforcement of an element at the end, the value of an element after the sorting algorithm has to match the value of the initial array, only applies to everything except for the last element. So that constraint does not apply to the last one, which means in this particular case, if I change this to 2 to the power of n minus 1, which is the largest value when n is the number of bits of an integer, it will still meet that requirement. But this is not sorting anymore. Okay, so I need to change that notation to cover that. Okay, I was being lazy. I was trying to use the same I to mean to deal with both, but it just not it is not working. Okay, so let me go ahead and change this, and you guys can tell me how to fix it.
While you're there, can you also unlock it for us? Or at least I think we just can't access it.
We can't access it.
You cannot?
Not available unless you achieve a required score in the first total.
Same.
In which activity?
Function.
Functions and relations.
Oh, I picked the wrong one. Okay, so I'll fix that too, but let's deal with this one first. Okay. Now this is how it appears when I'm editing this. It's all in LaTeX format. So what I need to do is to express one thing first, and then express the other one, after that. So let's check out this one. So we'll deal with the ordering first, and then we'll deal with the other one. So we'll do a wedge, and we'll close parentheses for all I, and 0 dots, and minus 1 in this case, so I can cover the last case. A bracket I has to equal to k subscript of f of I. Oops. There we go. And I think I need one more parentheses after this. There we go. Has anyone gotten into the habit of checking, the LaTeX representation? No, you guys don't care. Of the equations, of all the formula and equations that I typed.
I read it on that website.
Oh, okay. And I need to change the restrict access. Oh, no, it's applied. That one is for the entire topic. Save and display first. Make sure this is fixed, and then I'll go ahead and release the notes on that part. Okay. So I think this is right now. That makes it even longer. Okay, so let's take a look at this one and see and make sure that this is right. So I broke it up into two parts. The first part, which is this part here, is only enforcing that one element in the array has to be less than or equal to the one next to it. And then the second portion is this part here. But this time I goes from 0 to n minus 1. So it covers all the valid indexes into the array. And in that case, I enforce that a particular element has to match the value of some element from the beginning or the initial state of the array. So that will fix that problem. Yep.
Another question? The home rule, I can't go into a function.
Yeah, Chris just mentioned that. So I'm gonna make sure that it's released. Okay. And let's go back here. I picked the wrong requirement to meet in order to open it. So let's turn on editing. Yep, I picked course a course title must be 100%, which means you have to get a perfect score in order to read the notes in order to study to get a perfect score. And I really only meant to be, to use the interactive syllabus. I picked the wrong one. Okay, there we go. So as a result of that, I'm going to give you some extra time for this particular quiz. So that's, I'm going to change that to.
Did you say some people already started?
Yeah.
How's that possible?
They ran on them.
Because they probably clicked on it from the upcoming events. It might show up in the upcoming events. So I'm going to turn it to the 10th. All right, so the quiz is now, has a due date of the 10th of February, which is a long way out, okay? But you will still want to get it done as early as possible, okay? Because you will need these concepts in the other parts of the class. So you don't want to kind of defer the studying or getting the homework done. Get it done first, okay? If you have questions to ask in class, go ahead and ask those questions. It doesn't hurt to start early. I've never heard of someone complaining and saying, "Oh, I started early and I ended up wasting all the time." Yep, go ahead.
So the next homework is on 10th instead of 11th?
Yes, but I can lump other homework on top of this one too, so I'm not going to wait until the 10th before I have another homework assignment. Okay, it's just that for this one, I'll give you guys some extra time to work on it. Thank you, Chris, for letting me know.